Okay, so to solve number 22 on the first open response of chapter 6, I have something like this. So solve for v, okay? Don't forget to check for extraneous whenever they ask to. So here, I have log base 2 of v plus log base 2 of v minus 3. There is a property that we've taught you, properties of log. There's 3 of them. There's quotient, product, quotient, and power. So here, my two terms are separated with a plus, with an addition sign, so I know I'm going to have to use the product property, where the product property tells me that I take my two log terms, log base 2, my two terms, the v and the v minus 31, and I multiply it, right? That equals 5. Okay, so to undo the log base 2, we know that to undo a log, the inverse of that is an exponent. So to cancel this log base of 2, you need to give an exponent of 2 to both sides. Thanks to inverses, I have this exponent of 2, this log base of 2, which will cancel, leaving us with v times v minus 31 equals 2, and this here says 2 to the 5th. So 2 times 2 times 2 times 2 times 2, 32. Alright, I can distribute the v, so v squared minus 31v, that equals 32. Whenever you see a v squared and a v, I'm always going to think I'm going to factor it. To do so, I subtract 32 to both sides. I wish there was more room, but it's okay. So v squared minus 31v minus 32 is equal to 0, and then we factor this. So let's see, there are a lot of factors that go into 32. However, I need to add to 31. So right away, I know it's 32 and a 1. So a v and a v. Because I want to add to a negative 31, I know that 32 has to be negative, the 1 is positive, and we solve it. Okay, set each factor equal to 0. So here we get v equals 32, and then here we get v is equal to negative 1. I know you have two answers, but only one of them will work because one of them will be our extraneous solution. So let's see. You know what? Off to the side, like right here, underneath 35, I'll just finish the problem. Underneath 35. So I'll finish it here. So here we have to check. So I'm going to take my 32 and my negative 1, and I'm going to plug it into the original here, into both of the v's. So it's going to look something like this. It's going to look like log base 2 of v. Now I'll put parentheses. Plus log base 2 of v minus 31 equals to 5. And then the other one we have to do and plug in for negative 1. So the first one I'll plug in a 32, right? I'll plug in a 32 wherever I see the v's. So here's 32, and here is 32. I do the same thing, so log v, here I'm going to plug in a negative 1 plus log base 2, and it's negative 1 minus 31 equals to 5. And let's see if this works. Okay, so log base 2 of 32. So 2 to what power will give you 32? Answer is 5. Here is 32 minus 31. So that will end up giving us log base 2 of 1, right? 32 minus 31. And then 2 to what power will give you 1? The answer is 0, right? 2 to the 0 power. Does this equal 5? Yes, it does. So one of my answers is 32. Let's try it for -1. So log of -1. Log of -1. Let's see. So if I enter this into the calculator, log -1, right? Enter the calculator, push enter, error. So log of -1, we cannot simplify this. So this does not give us an answer. So the only answer we have, and I'll draw an arrow here, the only answer we have is 32. So -1 does not work. Okay, so make sure you check for extraneous. Okay, moving on. I have 23. I'm going to highlight my x value. In this case, the x is with the 4, and then the 4 to the x is an exponent for e. So I have to isolate what I just highlighted. So I'm going to subtract the 4 to both sides. So I get e to the 4x is equal to, that's 13 minus 4, so that's 9. So right now I have an exponent. To undo an exponent, I have to give a log. We know that e, the inverse of an e, is ln, so I do ln to both sides. And you know, if there is no base for ln, we imply it's base e. So that's why we're allowed to cancel these two, leaving us with 4x is equal to ln 9. I'm asked to solve for x, so I divide by 4. So ln 9 all over 4. Plug this into the calculator correctly. So it will say, sorry, I'm trying to position both. So it will say ln 9 divided by, thank you.
So much for letting us use your word.
No problem, thank you. So ln 9 divided by 4. Make sure you close the parentheses. Push enter. And then here's my decimal, 0.549. Okay. Sorry about the interruption. Somebody came in. Okay, so 0.549. Okay, so make sure you know how to enter this into the calculator. Okay, moving on to 24. So 24, Mary started her own business and is producing 150 purses each month. So 150 purses each month. She is able to sell as many as she is able to produce. She is estimating that she will be able to increase her production by 5% each month. Part A says write an equation that models the number of purses produced each month. And look here, we gave you the equation. You just need to figure out which one we're using. So Mary thinks that she can increase her production. So an increase means that we're doing the equation with the plus, not the minus. Minus is decrease. My A value is the initial, so how much she starts with. The rate is the rate at which she is increasing by. Don't forget to change that to percent. And then at this time, t is unknown. So we put it together. Y is equal to, A is 150. That's how much she starts with. 1 plus the rate. So she's saying that she can increase by 5%. To change 5% into a decimal, move it over twice. So you get 0.05, and then t is unknown, and then so here is your equation for part A. I mean, if you want to, I guess, add 1.05, you can, but this is fine, I think. Okay, part B says predict how many purses she will be able to produce in the 9th month. So this one is kind of tricky because a lot of students will assume, okay, I'm going to take the 9 and I'm going to plug it in for t. But here's the issue, okay, here's the issue. And the issue is this. So Mary started her business and is producing 150 each month. So right now I say that the first month, I'll do this, month, and then I'll say T. Okay, so the first month, right? The first month she starts with 150. So we say that T is not first, it's 0 because that's the start. So this is the start. So she starts at T equals 0. That's how much she started with the first month. After the second month, she produces more purses, so we say T equals 1. The third month, we say T equals 2. Okay, I'm looking for the ninth. So 4, 5, 6, 7, 8, 9. Oh, sorry, I didn't fit it. So the fourth month, T equals 3. Fifth month, time is 4. Sixth month, T equals 5. Seventh month, T equals 6. Eighth month is T equals 7. And then the ninth month, which is what we're looking for, T equals 8. So because, I know this one's tricky, because we started with the first month, she already produced purses in the first month. So we say that T equals 0. Okay, so right now, your thought is to plug in the 9 here. That's not the case. We have to plug in T equals 8 into the equation that we produced in part A. So that's 1 plus 0.05 to the 8th. And then we just plug it into the calculator. So that's 150, 1.05 to the 8th. Some students like to plug this all in. I mean, it's up to you. I can show you how to plug it all in. So that's 150. Give me parentheses. Close the parentheses. Give me an exponent to the 8th power. Enter. And then I say don't round. So 221 purses will be produced on the 9th month. Okay, all right, moving on to 25. 25 says to expand. Okay, so we're expanding this log expression here. So again, you have 3 properties of log: product, quotient, and power. So the first thing I want to tackle is the fact that I have a quotient here. I have division. So quotient property tells me that I take my numerator and I subtract it by my denominator. So it's going to look like this. Log base 3. My numerator is x to the second, y to the third. I subtract it by the denominator. Make sure the denominator has a log of z to the fifth. Make sure each of your expressions or each of your terms has a log base 3. Okay, that's like our foundation that allows us to work with all of these terms. Okay? Alright, so if you look at my first term, x to the second, y to the third, what are the x's and the y's doing to each other? Well, they are multiplying. So I'm going to use my product property. Product property tells me that I can expand this expression by adding my 2 terms. So it's going to say log base 3. I should probably write here. I applied the quotient. Quotient property was here. Okay, sorry, log base 3 of x to the second, and I'm adding it, right, because I'm using product property, log base 3 of y to the third, and I have minus log base 3 of z to the 5th. And this is, I use the product property here. Okay? Alright, so if you look at each term, each of them has an exponent. An exponent we know is something called a power. So we're going to use the power property, which tells us that the exponents, to expand it, will then become a coefficient. So it's going in front of each of my logs. So then it will say 2 times log base 3 of x. Sorry, I'm going to cover this up. Plus 3 times log base 3 of y, and then minus 5 log base 3 of z. And we've just expanded all of our terms. So this one is called the power. Okay, moving on to 26. Graphing. Okay, so 26, I have this graph here. So the first thing I need to find is my parent function, what my graph looks like. So I'm going to look like for something that looks like this, a times b to the x. So can you find it here on your function? I think it looks like my a value is 3, my b value is 2/5, and my x is just x. So I'm going to ignore the translations for now. Okay, what does this graph look like? Well, you make a table using as many points as you want, but I do 0 and 1. And you just plug it in. So 3, you plug in the 0 into this function, so it's going to say 3 times 2/5 to the 0 power. You know anything to the 0 power is just 1, so that's 3 times 1, which gives me 3. I plug in a 1, so 3 times 2/5 to the first power. Anything to the first power is just stays as is. Multiply those two fractions. I can put this over 1. You know, multiplying fractions, you just go across. So, oops, so that's 6 over 5, sorry. And then you put this into the calculator if you want to know. It's going to give you 1.2. So when I plug in a 1, I'll get 1.2. Okay, I can graph this. I'm going to use a pencil when I graph this table here. Okay, so let's graph it. So 0 up 3, and then 1, 1.2. So is this graph a growth or decay? Looks like it's going to be a decay. Right? Decay because my b value is less than 1. Okay, so my graph looks like this. With an asymptote currently at y equals 0. Okay, and then you shift your graph accordingly. This -2 here, that is your h value. It's always the opposite. So instead of left 2, we go right 2. This -2 here is my k value, so that goes up and down, so we say this one goes down 2. So then you take your 2 points that we graphed with pencil and shift them right 2, down 2, right 2, and down 2. So right 2, down 2, right 2, right 2, down 2. When my graph shifts accordingly, something shifts with it, and that is my asymptote. So right now the asymptote is at 0. Okay, so what happens, maybe you can see it this way. So what happens to my graph as I shift it right 2, and then down 2? My asymptote is now at y equals 2. Negative 2, I'm sorry. Okay, now I can graph my function. Okay. Okay, now that we graphed it, let's go back and answer those questions. Okay, so write out each steps of the translation. There was a stretch or a shrink by, well, the A value tells me if this is a stretch or a shrink. So right now, this A value is a 3. And because 3 is bigger than 1, we know it is a stretch by 3. Your graph moves left or right by, well, we wrote it here. It moves right by 2, right? 2 to the right. Your graph moves up or down by, well, we wrote here, it's down by 2. Sketch the asymptote. Yes, we did that. What's the equation? Well, thanks to the translation of your graph, it moved it down 2, giving it a horizontal asymptote at y equals negative 2. State the domain and range. Well, domain are your x values. We can tell we have a domain, or we can tell we have a vertical asymptote if it says x equals, but in this case it's y. So right now our graph is going to continue to grow on the x values, so there is no stop on the domain. So your graph exists everywhere, so we say all real numbers. The range, however, is your y. In this case, we do have a y asymptote, a horizontal asymptote at negative 2. So your graph, your asymptote is right here, your graph exists everywhere above this asymptote. So we say y is greater than negative 2. And then we graphed it. Okay, so let me just, so you can see the whole picture. Okay, so for 27, solve the following equation. So something you should notice about number 27 is that you have ln both sides, right? ln negative 2x plus 8, and then ln 5x minus 6. So then let me ask you, do you have, it's blurry, sorry, do you have an ln here or do you have an exponent? And the answer is ln, right? So to undo the ln, to find the inverse of ln, right? To find the inverse of ln, you have to give an e, right? E, the exponent. Okay, so we give an e to both sides. Right? If ln has no base, you say base is e, so that's why you're able to cancel both sides, leaving you with negative 2x plus 8 equals 5x minus 6. And then you solve from there. Okay, so you can easily solve this problem quite easily, right? So I'm going to say dot dot dot. Answer is 2, so make sure you know how to solve. Okay, moving on to 28. For 28, here's my x. X is with log base 3. The 6 I know is with that log base 3, but you can easily isolate it. So to get rid of the 8, get rid of the 6, we first subtract the 8 to both sides. That will give us 6 log base 3 of x equals to 12. To get rid of the 6, it's 6 times the log, so we divide by 6 to both sides. That's log base 3 of x equals to 2. Okay, so then my question is, do you right now have a log or do you have an exponent? And the answer is you have a log. Obviously it says log log. So to undo this log, you have to give an exponent. Right? To undo the log, you give an exponent because they are inverses of each other. So to get rid of this log base 3, you need to give an exponent of 3 to both sides. That way, thanks to inverses, they cancel. So x is equal to 3 to the second power, and 3 to the second power is 3 times 3, so that gives you 9. And it does say solve to 3 decimal places where appropriate. So obviously this is not appropriate to give it into 3 decimal places. Okay. 29, we are condensing using properties of log. You have 3 properties: product, quotient, and power. So let's look at what we have first. It looks like I have some coefficients in front. I have a 5 and I have a 4 coefficient. So I know that the power property allows me to bring a exponent down to the front and become an exponent. So to reverse that, we take those coefficients and then we move them back so that it becomes exponents. So it says log base 3 of x to the 5th power plus log base 3 of y to the 4th power. Okay, we can keep condensing. I have this, so I'll just write here, we did the power property. So we can keep condensing. I have this operation plus between my 2 logs. The property that tells me to go backwards is the product. So we have to take the x to the 5th, the y to the 4th, and multiply it to each other. So next property, I will use the product property, which tells me that I take my terms, so log base 3, I take the terms x to the 5th and y to the 4th and multiply them. And then we don't have any more operations like a subtraction or addition, so we are done condensing for 29. 30, I can locate my x. So I need to isolate what I've just highlighted, so I need to add 4 to both sides. I get ln 2x is equal to 4. Now let me ask you, do you have a log or do you have an exponent here? And the answer is you have a log, right? You have an ln. So to undo a log, you give an exponent. In this case, we have ln. So the inverse of ln is e. So we have to give an e to both sides. Right? We can do that because the base for ln is an e, so that they cancel each other out. You're left with 2x is equal to e to the 4th. And then e is just a button on your calculator that gives you the exponent, or if you can't find it, you can use 2.71. I can do one more step, get rid of that 2 by dividing by 2. So you put this into the calculator, e to the 4th all over 2. So several students do it a different way. I can do, there's my E button right here, right above the ln. So I can shift ln to get E, and that's to the 4th power. I could push enter, and then I need to divide this by 2. push enter. So x equals, we say about 27.299. Okay, and then the last one for the open response. Identify where your x is. X is right there, 7 to the 4th x power. Isolate what you just highlighted, so add the 5 to both sides. So it says 7 to the 4x power is equal to 7. So then let me ask you something. Do you have here an exponent or a log? Exponent or a log? Well, you have an exponent. So to undo an exponent, you give a log because they are inverses of each other. So specifically, to get rid of the 7, you log base 7 to both sides. Right? They are inverses of each other. They cancel. I'm left with 4x is equal to, the right side says log base 7 of 7. Which log base 7 of 7, that equals 1. This is 1 right here. Right? Because 7 to the first power is 7. Or you can also see that they are inverses, so they cancel. And whenever you cancel terms in math, you're left with the 1. Okay, so equals 4x. Pretty simple to solve from here. Divide by 4 to both sides. So x equals 1/4.